everyone, in today's video, let us see how to find the area between the curve and the x-axis. So these are some steps you need to remember if you want to find out the area between a given curve and the x-axis. So suppose if you have a function given, a function of x and the x-axis, and the interval is supposed to be a comma b, a closed interval, then the first point to be followed is to subdivide the given interval at the zeros of f. That is, we equate the given function to 0 and we see what are the values of x we get. So that is meant by subdividing the interval a comma b at the zeros of f. Next is we integrate f using all those points that we get, and then we are going to add the absolute values of the integral. So absolute values means we are going to take only the positive values of the integral. Okay, let's look into the example. So here we have a first example where find the area of the region between the x-axis and the graph of function f of x cube minus x square minus of 2x in the interval minus 1 comma 2. So it is a closed interval minus 1 comma 2. So the graph of this equation, this function appears in this form. So this is the type of graph. So let's see the solution for this example. So here the given function is f of x is equal to x cube minus x square minus 2x. For the first thing we have to do here is to find the zeros of f. So for getting zeros of f of x, that is x cube minus x square minus 2x, we consider the function equal to 0. We take f of x is equal to 0. So what is f of x here? It is x cube minus x square minus 2x is equal to 0. We simplify this equation, so we can see x is common everywhere. So take x common, we get x square minus x minus of 2 is equal to 0. Now equate each of them to 0. X is equal to 0. X square minus x minus 2 is equal to 0. If we solve this quadratic equation, we obtain x plus 1, x minus 2 is equal to 0. Okay, we are going to solve this quadratic equation and we get x plus 1, x minus 2 is equal to 0. So we obtain here x is equal to 0. Therefore, x is equal to 0, x is equal to minus 1, x is equal to 2 are zeros of f. So if we now look at the given interval. So the given interval is 1 comma 2, minus 1 and 2 was the given points, and they are asking us to find out the area in this given interval, right, from minus 1 to 2. So it is a region, that is the area between the x-axis and the given function. So this is the curve between for the given function between minus 1 to 2. So we have to find out this area. Okay, so this is the two areas that are required. So if you look at the zeros of f, one is x is equal to 0, which is here where the graph is moving in the downward of x-axis. Then we have x is equal to minus 1, which is already given, and you have x is equal to 2. So we can see here the given curve can be divided into two parts. One is above the x-axis and one is below the x-axis. So how do we solve this? So this we got. Now we have to check if you're not known what kind of graph you're getting. So how do you know if it is giving you a positive area or a negative area? So that is to determine if it is lying above the x-axis or below the x-axis. So what we do is we consider any one point in between the given interval. So suppose our interval is minus 1 to 0. So we consider the point as minus 0.5. And here we can consider it as 1, a point in the interval 0 to 2. So we put this value in the given function and check what is the value of the function. So if I put minus of 0.5 in the given value, that is minus 0.5 cubed minus 0.5 square minus of 2 times minus of 0.5. If I'm putting this value in this given function, then I am going to get a positive value. Okay, you can just check it using a calculator. So this will be giving a positive value. Similarly, if I put 1 in this given equation, that is 1 cube minus 1 squared minus 2 times 1. So here you can see it is 1 cube is 1 minus 1 is 0. So I am going to get a negative value. So this itself says you if that curve is lying above the x-axis or below the x-axis. So since it is lying above the x-axis, here you get a positive value. And since this curve is lying below the x-axis, we get the value of f of 1 as negative. So what I have done basically, I have taken one point in the given interval minus 1 to 0 to show it is above the x-axis, and I have taken one point in the interval 0 to 2. You can take any point. It might be 0 0.5, it can be 1.25, 1.5, anything. So basically you will be getting only positive and negative value. So that is just to check if your curve is lying above the x-axis or it is lying below the x-axis. So we are clear here with the idea that the curve is lying above axis first half, and the next remaining part is lying below the x-axis. So what we do after we find out the zeros of f, the next step is to subdivide the interval. So what we have to find out area, the formula is integral a to b f of x dx. But here given interval was minus 1 to 2 f of x dx. But we can see that this interval minus 1 to 2 is been divided into two parts using a 0. So we rewrite this as minus 1 to 0 f of x dx plus integral 0 to 2 f of x dx using the additive property of integrals. So this is how we have written this. Now we are going to find out the value of these two integrals separately, and then we are going to add them up. So finding out the first integral now. So we know f of x value, just we are going to put the value of f of x. So integral minus 1 to 0 f of x value, that is x cube minus x square minus 2x dx. So if you integrate this, x cube changes to x power 4 by 4, x square will be x cube by 3 minus 2, x will be x square over 2. So basically what happens in integration, the power is going to increase by 1 and the same power will come in the denominator. And once you integrate, we are going to apply the upper limit and the lower limit. So once done with this, we are going to apply the upper limit and lower limit. So first applying the upper limit minus the lower limit. So since the upper limit is 0 and you have x in each of the places, everywhere will be 0. So it is 0 minus of the lower limit. Lower limit minus 1. So it is minus 1 power 4 by 4 minus of minus 1 power 3 by 3 minus of 2 times minus 1 power 2 divided by 2. So we simplify this. So minus 1 power 4 is 1. Negative number raised to a positive power is always positive, by 4 minus of minus raised to a odd power will be always negative. So this changes to plus of 1 over 3. Minus of minus is plus. Then again a minus raised to even power will be always positive. So it is 2 over 2, which is equal to 1. So instead of writing 2 over 2, I am going to write it as 1. Now if you simplify this, minus of, okay, so if you take the LCM, so this will be 3 plus 4 minus of 4 times 3 is 12 divided by 12. 4 times 3 is 12. So 4 plus 3 is 7. 7 minus 7 minus of 12 is 5. So minus 5 by 12. So minus of minus will be plus. So in this case, I get the answer as 5 over 12. So again, since the area, the curve is lying above the x-axis, this area will be positive. So I have obtained the answer here as 5 over 12. So this is equal to 5 over 12. I'll go for the next one, that is integral 0 to 2. You can look at this. Again, I am going to solve this one. 0 to 2. F of x is x cube minus x square minus 2x. X cube minus x square minus of 2x dx. Again integrating, same as we did for the previous one. So it becomes x power 4 by 4 minus x cube by 3 minus 2x square over 2. In the previous one, I just forgot to cancel these two. So if you are willing to, you can cancel it in this step itself as they are equal. And then we can apply the upper limit and lower limit. So in this case, the upper limit is 2. So applying 2 wherever you have x. So it will be 2 power 4 over 4 minus 2 power 3 over 3 minus of 2 square. And this is the upper limit minus lower limit. 0, 0 and 0. So this will be 0. So if you simplify this, 2 power 4. So we can write it as 2 power 4 is 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16 by 4 minus 2 cube is 8 over 3 minus 2 square is 4 and minus of 0 can be left off. So 16 by 4 will be 4 minus of 8 over 3 minus of 4. So in this case, plus 4 minus 4 are getting cancelled. So I get the answer as minus of 8 over 3. And also again, if we cross check, the curve was lying below the x-axis and so the area is negative in this case. So once you solve both the integrals, so therefore the total area can be found out now. The total area enclosed between the curve and x-axis is, so it is area equals, so we had the two integrals, that is, as I told you, we are going to look into the absolute values. So one was 5 over 12 and the plus of the another value. Since it is negative, it is mod of minus 8 over 3, that will be changing to positive because area cannot be a negative value. So both those curves should have a negative value, both the parts of the curve. So it is 5 over 12 plus of 8 over 3. If you take the LCM here, you get 5 times 3 15, then plus 8 times 12 is 96 divided by 12 times 3. So if you simplify this, I think it is 111 over 12 times 3 and this gets simplified to 37 over 2. And this is your value for the interval. So you can, since it is area, you can just mention it as units. So let's look into another example of the same type. Find the area of the region between the curve f of x is equal to 3x square minus 3 and the x-axis on the interval minus 2 to. So the graph for this function appears somewhat in this type. Okay, a curve which is going below the x-axis and again turning up. So you can see from minus 1 to 1, the curve is below the x-axis and the remaining part is above the x-axis. So let's see if we are going to get the same thing when we are solving the f of x for zeros of x. For the first thing we are doing is we are going to get the zeros of x. For zeros of x, zeros of f of x, that is 3x square minus 3, we take f of x is equal to 0. That is 3x square minus 3 is equal to 0. If you simplify this, take 3 common, we get x square minus 1 is equal to 0. 3, you can skip it off, 3 equal to 0 not possible. So we have x square minus 1 is equal to 0. Therefore, x square minus 1 is equal to 0. So it's in the form of a square minus b square. So it is x square minus 1 square, that can be written as x plus 1, x minus 1 equal to 0. So therefore, zeros of f are x is equal to, if you simplify this, we get x is equal to minus 1 and this will give us x is equal to plus 1. So we have got 2 points now. Let's look into the graph. So already it was given in the graph, it is -2 in the question, -2, and we had a 2. But now if you look into, we are getting 2 points for x, that is -1 and 1. So now basically this given interval -2, 2 is being divided into 1, 2 and 3 subintervals. Okay. So these are the 3 subintervals. So you can see in the first interval, the graph is positive because it is lying above the x-axis. Here the graph is negative, so the area also will be negative here. Here it is positive. Let's check if it is the same thing. So what I do is I take some number here. Maybe from -1 to -2, I can take it as minus of 1.5 as my value. Here I can take 0 as my value, and here I can take 1.5 as my value. So if I put this in the equation, that is f of minus 1.5. So it is 3 times minus 1.5 square minus 3. I have to check the value for this. F of 0, that can be got easily, that is 3 times 0 minus 3. And f of 1.5, that is equal to 3 times 1.5 square minus of 3. So now if I see minus of 1.5 squared, so it will be a positive value. So positive 1.5 will be a bigger number. So that number minus of 3 will be always a positive value. 3 times 0 is 0. 0 minus 3 is minus 3. So a negative value. Here it is a positive, bigger value minus a smaller value will be always a positive value. So as I mentioned, first graph is positive, second subinterval is negative. Here also it is positive. So it's not required a graph. So looking for such type of substitution also we get the exact value. So now the second step here is to find out the area. That is to divide into a different subintervals. Here the given interval is -2 to 2 f of x dx. So dividing this into the different subintervals, that is the 3 intervals. So looking to the graph, we can write this as -2 to -1 f of x dx is first subinterval, plus the second interval -1 to 1, -1 to 1 f of x dx, plus integral 1 to 2, 1 to 2 f of x dx. So we have got the 3 subintervals, so we'll find each one of them separately, and then we are going to add the absolute values. So first one, integral -2 to -1 f of x, that is given here to be 3x square minus 3 and dx. So if I simplify this, that is if I integrate this, keeping 3 as it is, x square, power increases, so it is x cube, and the same power in the denominator, minus 3. Since 3 is a constant, integration of 3 will be 3x. And we are going to simplify this from -2 to -1. So this both can be cancelled. So now applying the upper limit first. Upper limit is -1. -1 cubed, minus of 3 times -1. So upper limit minus the lower limit. What is the lower limit? Lower limit is -2. So it is -2 cubed, minus of 3 times -2, close the bracket. So -1 power 3. So negative number raised to odd number will be always negative. So it is -1 in this case. So minus of minus will be plus. It is plus of 3. Here a minus. I'll keep this inside the bracket. So -2 negative power will be, odd number will be negative. So 2 cube, 2 times 2 is 4. 4 times 2 is 8. Minus of minus will be plus. So it is 3 times 2, which is 6. So now for the simplification, 3 minus 1 will be 2, and here minus of -8 plus 6 is again -2. So if I simplify this, minus of minus will be plus, 2 plus 2 will be 4. So this is my answer for the first subinterval. So calculating for the second interval, that is -1 to 1, 3x square minus 3. So second one, and integral -1 to 1. Question is 3x square minus 3 dx. Let's cross check. It is -1 to 1, 3x square minus 3. Simplifying this, first integrate. So 3 as it is, x square, x cube by 3, 3 is a constant, it becomes 3x, and then integrating from -1 to 1. So 3 and 3 cancels, upper limit is 1, so it is 1 cubed minus of 3 times 1 minus of the lower limit, that is minus 1 power 3 minus of 3 times minus 1. So if I simplify this further, 1 cube will be 1 minus of 3 minus in the bracket minus 1 cubed, again a odd number with a negative number, so it is minus of 1 minus of minus will be plus 3. So if I simplify this, minus 2 minus of minus 1 plus 3 is 2, so minus 2 will be minus of 4. So as I told you, the second part was below the x-axis, so I get the answer as negative. Also, the last one was integral 1 to 2, if I'm not wrong. So integral is 1 to 2 f of x. 1 to 2, 3x square minus 3. So now again integrate 3 as it is, x square will be x cube by 3 minus 3 as it is, and x, because it is a constant, integrating from 1 to 2, 3 and 3 cancels, upper limit 2 cube minus of 3 times 2 minus upper limit in the bracket minus again the lower limit. So 1 cube minus of 3 times 1. Simplifying, 2 times 2 cube, 2 times 2 4, 4 times 2 is 8, minus 3 times 2 is 6, minus of, here inside the bracket 1 cube is 1, minus 3. Simplifying, 8 minus 6, 2, minus of 1 minus 3 is minus 2 again. So minus of minus plus, so 2 plus 2, which will be equal to 4. So we have simplified all the subintervals. Therefore, total area enclosed between the curve and x-axis. Also remember, we are not taking any points which are given outside the interval. Here the interval was only -2 to 2. So we consider only the points which are coming in that interval. Okay. So area will be equal to the sum of all the three subintervals. So first answer was 4. That is positive. Keep it as it is. Second interval is giving you the value as negative. So whenever you have a negative value, we are going to find out the absolute value. So keep it inside the mod plus of the third value, which is already a positive value. So if you solve this now, 4, absolute value of -4 will be 4 plus of 4. And on adding all the three, 4 plus 4 is 8, 8 plus 4 is 12. So here in this case, area will be equal to 12 units. And this is how we are going to find out the area between the curve and the x-axis. So thanks for watching my video. If you like my videos, please like, share and subscribe. For more videos, please comment below.